let's look at how you divide one polynomial by another. This is akin to factoring, but this will always work even if the divisor that you're using isn't exactly a factor of of the dividend that you're trying to divide. It will come out with a remainder very often, but we can do this in a way that will always work. It's exactly analogous to long division of numbers, which is maybe not everybody's favorite algorithm, but it should be familiar. The book makes that analogy a little more precise. I recommend you look at that. I'm just going to jump into an example and show how it works. In some ways, it's actually a little easier than the numeric case, honestly. So we're trying to divide x minus 4 into 2x cubed minus 3x squared minus 10x minus 7. It's only going to make sense if the degree of the dividend, what we're trying to divide into, that's this guy, is greater than or equal to the degree of this guy. This is the divisor. So it's analogous to ordinary numeric long division, as I said. We focus on the highest degree piece, the leading terms, and only the leading terms right at the moment. And we ask, does x go into 2x cubed? And if so, how? So we're really just dividing monomials. Well, yeah, we're just basically saying, what's 2x cubed divided by x? It's almost as if we're temporarily ignoring all the rest of the polynomial. And indeed, 2x cubed divided by x is just 2x squared. Oops. Okay, so we put that up there, very much like in the long division story. And very much like that story as well, we're going to take that 2x squared and we're going to multiply it by x minus 4. We're basically taking out of this the stuff that we know fits. So we know 2x squared times x doesn't exceed what we have here. It matches what we have here. And so we'll write that down. So we're multiplying this monomial by this very simple binomial. 2x squared times minus 4, that's a minus 8x squared. Okay, so we've discovered that 2x squared times x minus 4 matches the leading term exactly. Whoops, don't want to delete it. And then it doesn't match this term, but and of course it doesn't match these guys, but we're going to compare. We're going to say, well, what's left over, right? And this is a very common thing with long division, okay? So now we subtract off, and the whole point is that these guys match, so that will give us 0. Now we have to be very careful with the signs. We got minus 3x squared, and we're subtracting this stuff. So it's minus 3x squared minus a minus 8x squared. That's going to give us, let's move over, it's going to give us a plus 5x squared. It's the kind of thing you might want to do in a sidebar calculation to make sure, at least the first few times, to make sure you're getting the signs right. You're taking this top polynomial, subtracting the bottom, and that's going to flip every sign. Now, just like in ordinary numeric stuff, if there's anything left, you're just, I don't really need that extra space, you're going to just bring it down. So that's really just subtracting, but in a certain kind of visual tableau. Okay, now we say, well, there's still more stuff that x minus 4 might go into. In particular, when you go back to focusing on the leading terms, x does go into 5x squared. How many times? That's just 5x squared divided by x. That's 5x. Okay, so 2x squared times x minus 4 is all this stuff, but we've accounted for that, this second line. Now I'm going to put in the 5x times x minus 4 as more stuff that we've accounted for. That is 5x squared minus 20x. So we're just multiplying the new piece of the quotient that we're building times the dividend. That's the divisor. Okay. Now we compare. Well, we've accounted for more stuff. What's still left over? And that's where we're going to, let's see if I can do this quickly. Yeah, underline. Okay. So we're going to go, let me space over. We're going to subtract that out. The 5x squared will die. They cancel. Minus 10x minus a minus 20x. So that's plus a 20x. So in all, that's going to be a 10x. And the minus 7 is still there. Okay. Almost there, but x still can go into 10x. Notice that the degree of this current version of the polynomial that I've subtracted off all this good stuff that I've been able to match, That degree is 1. That's still equal to this. You're still going. You're not at the remainder stage yet, but we're really close. This is about the last. This is very close to the end. X goes into 10x 10 times. And then if I take 10 times x minus 4, it's going to produce a 10x minus 40. And then I'm going to subtract those, make my little underline here. There we go. And space over here. It's a little bit tricky to do the spaces in the math mode here. The 10x's are going to die by design. A minus 7 minus a minus 40, that's minus 7 plus 40, that's 33. Now what is this? If you remember from ordinary long division, that's the remainder. So the fact that that's not 0 tells us that x minus 4 did not divide perfectly into this guy. So it's not a factor of this, which is a little disappointing. It's great when we see a remainder 0, and that says it is a factor. But typically, it's not going to be. And then let's see how we could write this. So this is the tableau that's going to do the job of doing the calculation for us. But what have we discovered? Well, we've discovered if we want to write it in just ordinary algebra without the fancy picture with where it puts in various slots, we've said that this polynomial can be created by taking x minus 4 times 2x squared plus 5x plus 10, but you won't get exactly this polynomial on the left-hand side. You will need to add the remainder. So that's that's a multiplication. I would call that a multiplication and addition equation. You could also say, if I actually write the quotient, I say this thing divided by x minus 4, that is equal to this polynomial plus, and then the remainder divided by the divisor. So these are totally equivalent. If you multiply the bottom equation by x minus 4 throughout, you get the top equation. If you take the top equation and you divide everything in it by x minus 4, you get the bottom equation. It's just the same as saying, if I say 37 equals 5 times 6 plus 2, it's equivalent to saying 37 over 5 is 6 plus 2/5. Or even, we often write that as a mixed number. And so this is kind of the mixed number version of it, saying that when you divide this cubic polynomial by this linear x minus 4, you get this as the main part, that's the quotient, but because it didn't divide evenly, you get the remainder divided by the divisor. This is a little more elegant here, and sometimes this is what we really care about. It's that I can create the big polynomial as a product with a little extra help from this remainder. So let me do a little more complicated one. Actually, I'll make that a second video because that's sort of the very, very basics of it. I'll do one more complicated one, and then I'll actually go back to that first example and show you how you can really, really streamline this when this is in this special form, just like x plus or minus a number. But I'll split it into 2 parts.